looking at this, I can tell three things. What's one thing you can tell just looking at the function, Cameron?
Y-intercept is 9.
The y-intercept is 9. What else can I tell just looking at this? It opens up. And if it opens up, I can tell it is a minimum. All right, so we know those three things just from the general form. Okay, now we're going to put it in standard form. Now it says by completing the square, which means you need to go through this process. There's, you can put it in general form without doing this. So the first thing we're going to do is move the 9 over. So just get him out of the way. Now if you look on Math Excel, when you help me with this, they don't move it to the left side. They just kind of keep it and they start adding and subtracting things. I think it's easier, if you get that idea, that's fine, but I think it's easier to move it. All right, next step is to factor out the A. So we're going to factor out the A. Then you have to find half of the new B squared. So half of 6 is 2. I'm sorry, half of 6 is 3. Squared is 9. That's what we're going to add to that parenthesis. Yes? Cameron?
Would it always be is 3 the A value in this one?
3 is the A value in this
Would
one.
it always be A squared?
No, it will never always be A squared. I mean, it's coincidence that it's A squared this time. It's half of that 6 squared. It has nothing to do with the 3. Okay, that's coincidence. So when I factor, what are we going to add to the left side? 27, right? Because remember, that 9 is getting multiplied by 3. Okay. So on the left, I have y plus 18. On the right, I'm going to have 3 times, and we're going to do a binomial square here. We made it so it's going to be a binomial square. What's inside there? X plus 3. It's always going to be x plus that half guy that we did. And then our last step would be to get the y by itself, move the 18 back over. So now that's in standard form. It's really only 4 steps. Move that c value, factor out the a, make it a perfect square trinomial, and put it in factored form. Okay? All right, what is the vertex then? -3, -18. Now this is the thing that, let's say I keep screwing up the completing square and I don't know how to do it. Can you still find the vertex doing opposite of b over 2a and then plug it in to find the y? You have that option. Okay? All right, find the line of symmetry. X equals -3. And then we'll go down here and find the x-intercepts. But first, let's go ahead and graph this. We're going to do the y-axis. It's going to be by 2s. So we've got -3, 2, 4, 6, 8, 10, 12. Here's -3, 18. Our axis of symmetry I'm going to sketch in there is that x equals -3. Our y-intercept is at 9, 2, 4, 6, 8, 9. The axis of symmetry is a mirror, so whatever's on the left or the right side of it's going to be on the left side, same distance. So I have my 3 points. I only need 3 points to graph this, right? So, and I can never sketch these nice and pretty. We're going to try it. That's the best one I've done all day. Okay? So, let's go ahead and find the x-intercepts. Because we're not going to go by what that graph says. It looks kind of ugly. So x-intercept 0 equals 3x squared plus 18x. Plus 9? Plus 9. So we're going to factor first. Always try to factor. So I can factor out a 3. Even if the quadratic part cannot factor, which this one cannot, we have made the number smaller. The smaller the numbers, the easier it's going to be for you. Okay? So this quadratic can't be factored, so we're going to do the quadratic formula. The 3 is just noise at this point. Just ignore it. So x equals opposite of b, plus or minus b squared minus 4 times a times c, all over 2 times a. Okay? Now, on Math Excel, some of you guys kind of got stuck on this. I don't know what is going on here. It's -6 plus or minus the square root of 24. If you type that in Math Excel, it's going to say you're wrong. Okay? So, you need to be able to break down the radical. So what perfect square goes into 24? 4. So that's 4 times 6. So the square root of 4 is a 2. The square root of 6 you have to leave like that, divided by 2. That's still not simplified enough. Basically, if all three of these numbers can be divided by a common factor, you need to divide it out. So I'm going to divide them all by 2. The radical does not get divided, just the number in front. That's the answer the Math Excel wants. That's the answer that I want on the test. Okay, those are your x-intercepts. If you were to actually put that in your calculator and get the 2 decimal approximated answers, I do believe this one is -0.55 and this one is -5.45. Something to that effect. And if you look at our graph, that's about where they'd be if I had graphed it nice and neat. All right? We okay? That's yesterday. So start on that Math Excel. Make sure you can get her done. When did you do? Friday. Okay? So get her done. All right. Today we're going to talk about polynomials. So quadratics are a polynomial. We're going to do all the other polynomials also today. Again, some of the stuff is going to be, oh, I know that already. We know that. All that good stuff. And then there's going to be new stuff. Okay? So, you have a Math Excel. It's due, I do believe, on Tuesday. So this just looks like a lot of noise. If I have a polynomial, let's write one here. Y equals 3x minus 5 plus 2x squared minus 6x to the 5th plus 7x cubed. Okay, that's a polynomial. Can anyone tell me what the degree is? 5, right? The highest exponent is the degree. So this is not written in standard form. Standard form would put the degree term first, and then the exponents would descend from there. Okay, so our degree is 5. The coefficients are the numbers that are in front of your x terms. Okay, so the leading coefficient is -6. The coefficient that does not have an x is called the constant. What is that on the graph? The y-intercept, right? So that number that's by himself, this little -5, is your y-intercept. All right? So that's basically what all this stuff says. If you have a degree 1, it is linear. Degree 2 is called a quadratic. So the problem is correct. You want to say quadratic. Degree 3 is a cubic. Degree 4 is a quartic. Degree 5 is a quintic. So I know you did those last year, whether you remember those words or not, but you need to know those. So linear, quadratic, cubic, quartic, and quintic. All right? So you need to know how to put it in standard form. Most of our answers we want to write in standard form, descending polynomials. The degree is important. The leading coefficient is important. The constant is important. Okay. All right. So 3 things about polynomials. First, the domain of every polynomial is all reals. If the domain is not all reals, then it is not a polynomial. The domain must be all reals. Okay. Secondly, the graph of a polynomial is a continuous curve. There are no breaks. So this guy, which looks like he's from a piecewise, is not a polynomial because there is a break. Even though that guy's domain is all reals. There's a break vertically. Okay. The graph of a polynomial is smooth. So you can't have sharp corners. Sharp corners causes it not to be a polynomial. What parent function did we talk about has a sharp corner? Absolute values. So absolute values are not polynomials. Okay? It's going to cause that sharp turn. It's got to be a nice, smooth, continuous curve from negative infinity to positive infinity on the domain. All right? So we're going to look at some functions, some equations, and determine if they are polynomials, yes or no. Okay? All right. These guys got really big. I'm going to shrink it up here. Okay, the first one. So in order for it to be a polynomial, the first thing we said is it has to have a domain of all reals. The domain of this guy is x cannot equal 1. Okay? So the domain is not all reals. So it's not a polynomial. Okay, what about the second one? Why not?
0 squared.
It's got to be greater than or equal to 0. So you can have no negatives here. So the domain is not all reals. So if there's ever a restriction, it cannot be a polynomial. What about this next one? What does the negative 2 exponent do? In reality, how could I rewrite this? The square's in the denominator, right? You can't have a negative exponent, it has to go downstairs. So x cannot equal 0. So again, the domain is not all real. So all of those have restrictions. The exponents in polynomials are 0 and higher whole numbers. They can't be negatives. They can't be fractions. Okay? Negative exponents causes that x to end up in the denominator. All right, the fourth one here. Does that look good? Okay, so this is, what's the degree? Degree is 4. And the leading coefficient is negative 7. So you need to be able to pick those. So what is the constant? 3. And so that is the y-intercept. Okay, so those are the things you're going to think about. All right, how about f of x equals 8? Yes, the exponent with the x that's not there is actually a 0. Because x to the 0 is 1. So we don't write that. It's invisible. But he's still there. So yes, it's a polynomial. The degree is 0. The leading coefficient is 8. Okay. And then this guy, what do you think, Cameron?
I was asking the last one, would there be a y-intercept for that one?
The y-intercept is 8. It's also a constant, right? These are horizontal lines. It's going to cross at 8. Okay, what about the last one? Isn't he okay? The exponents are 0 or higher. So yes, it's okay that the coefficient is irrational. It matters not. It's the exponents that we were concerned about. Okay? All right, so we can tell if it's a polynomial, yes or no? Okay. Now we're going to talk about power functions. Power functions are basic monomials. So it's one term. You're looking at, if it's an even degree, they all look like the parabola. Some version of it. I don't care if it's x to the second, x to the fourth, or x to the 28th. The graphs will look like this. If it's an odd power, the graphs all look like the cubic. So x to the 13th looks like this. X to the 3rd looks like this. Okay? So that's just things you need to know. Even power functions look like the parabola. Odd power functions look like the cubic. Has the same general shape. monomials. So, the reason being that we need to know even and odd powers. Not so much the power functions, they don't shift off. Here, this is even because it folds over the y-axis. Even exponents, odd, rotates around the origin, has odd exponents. We're going to talk about the limits of polynomials. Now, these aren't all power functions. They're any polynomial, okay? But the power functions we need to know because that's how we're going to tell them. So, if it's an odd degree, it has the same in behavior as that cubic. Okay? And when we talk about limits, the word limit is going to be used a lot now that you're in upper level math. It's just asking what is the height approaching as x goes to a certain number. That's what limit means. What's the height approaching? Okay? So when I say, what's the limit? Let's see if I can bring this up a little bit. This is how we want to write it. What's the limit of the function as x approaches infinity? So if you're looking at this function, as x approaches infinity, on the right side, the graph is going where? Up. So it's infinity. On the left side, as x is going to negative infinity, where's the graph going? Down to negative infinity. That's if we have an odd power, let's say to the fifth, and we have a positive coefficient. That's a positive graph. As soon as I put a negative in front of that 6, what happens to my graph? It flips. So now, as x goes to the negative side, where's my height going to? Up to the positive. As x goes to the positive side, my height is going to the negative. Okay? So you just have to think of the power functions. What do they look like? This stuff in between doesn't matter. We are talking limits of the end behavior. They call them end behaviors. You have a left behavior and a right behavior. As x goes to negative infinity, as x goes to positive infinity. Okay? How you write them is important. I don't know what they did last year. Some did this. Right? This is how we're going to write them. Okay? All right. So, if it's even, think about it. If I have a positive quadratic, I look like this, right? They're both going up. So both ends are going to positive infinity. If it's a negative quadratic, they're both going down to negative infinity. Okay, either side. So if you just know the power functions and positives and negatives, you're going to be in good shape. Okay? So, we're going to try a couple. It does not matter about anything except the leading term, the one that has the degree. So, this is what? Even or odd degree? Even degree, yes? Is it positive or negative? So, show me with your hands what that graph looks like. Like this, right? We're going down. So on my paper, I would always just kind of sketch this. So what is the end behavior on the left? Where's it going? Negative infinity. On the right, it's also going to negative infinity. You need to be able to write it. So it's the limit of the function as x approaches negative infinity, is on the left. And the limit of the function as x approaches positive infinity on the right, it's still going down. Okay? So all this other stuff, the 3x squared plus 4, that's just the stuff in the middle that we don't care about. The ups and downs that the graph's going to go in the middle. And right now, we're only talking about the ends. So in the next one, we have an even or odd. Odd. Positive or negative? Positive. So on the left side, where's the graph going? Negative infinity. On the right side, where's the graph going? Up to positive infinity, right? And we're talking about height of the graph. You just have to know the basic shapes of the power functions to be able to do these. Okay, and know if you put a negative, it flips the graph. It'll flip the end behaviors. Okay, does it make sense? Crystal clear, Mrs. Stewart. Okay. Zeros of polynomials. So the real zeros of polynomials. You find them by setting a function like this guy equal to 0 and factoring it and solving it. So they're called solutions. They're sometimes called roots. And if I'm on a graph, they are the x-intercepts. So all of those things are basically the same thing. The zero of the equation of the function is the solution or root when you set the function equal to 0, which causes it to hit the x-axis, which is the x-intercept. Okay, so they want you to know all of those are equivalent things. So let's find the real zeros of this first function. And we are going to factor, and I know you guys love it. Factor out the x. And then factor anything further that we can. So this is a quadratic. Factors of 3 that add to a negative 4. Negative 3, negative 1. So we're going to set each of these factors equal to 0. So when I set x equal to 0, I get 0. When I set x minus 3 equal to 0, I get 3. And when I set x minus 1 equal to 0, I get 1. Those are our solutions, our roots, our x-intercepts. All right? You guys try the second one there. All right. Okay, this next one, it's 4 terms. When we talked about this the other day, we're going to split that in half and factor by grouping. So on the left side, my greatest common factor is x squared. And on the right side, my greatest common factor is a 2. So now my 2x minus 3 is a greatest common factor. So we're going to pull him out front. And then what do we have left from each set? We have x squared plus 2. So that's a factoring technique that if you're not familiar with it, you just got to remember the steps. So 2x minus 3 equals 0. We're going to add 3 and divide 2. So it's x equals 3 over 2. X squared plus 2 equals 0. Now, whether you recognize it right now or not, that's impossible. X squared is, the lowest it can be is 0, so you already have it up to 2. Can't go any lower than 2. But let's continue. When you get to this step, x squared equals negative 2. When you go to take the square root, what's going to happen? You can't do it. You can do it, but you're not going to get real answers. So you just ignore that. This does not give me real answers. I'm looking for real zeros. Later on, we're going to get all the zeros, and that would be a plus or minus 2. What do you put outside when it's imaginary? An I. Okay, so we will get to those, but not today. Not in this lesson. Okay? Real solutions is all we're looking for. All right. Try the second one. See how you do. We good so far? All right. Let's do one more slide. The intermediate value theorem basically says, let A and B be two numbers such that A is smaller than B. If f is a polynomial such that f of A and f of B have opposite signs, then there's at least one number, C, with A is less than C, which is less than B, for which f of C equals 0. So let's just look at the graph and make sure we understand what this means. Here's my A, this is an x, and this is my f of A. Here's my B, bigger than A, and here's my f of B. So f of A is negative in this case, f of B is positive. If this is a continuous curve, what must have happened if I went from a negative to a positive? What happened? We had to cross over what number? 0. So there's some 0 that exists between A and B. So if you evaluate your function with two numbers, and one answer is positive and one answer is negative, you had to hit a 0 in between. So this is a way where you can estimate what your answers are. Okay, this always works with polynomials because polynomials are continuous functions. All right, this trick only works if you have a continuous function like a polynomial. Okay, in between those two. All right, so let's look what this really means. We're just going to do one of these. Use your calculators. Plug in 2 to this function and plug in 3 to this function and tell me what answers you get. I get negative 19 for the first one. And positive 147 for the second one. So that means I have a negative and a positive answer. There's got to be a 0 that exists between the interval 2 and 3. Right? Which one is it closest to? 2 or 3? 2, right? Negative 19 is closer to 0 than 147. So if I wanted to go further and try to check it, I'm going to say, let's try 2.5. Up in 2.5 and see what you get. This guy's a lot lower. Getting closer, aren't I? What about 2.4? I'm at 12 point. .8. So now we're almost even, Steven. One's negative 19, one's 12.8. Which is it closer to? 2 or 2.4? Which is closer to 0? 2, f of, or p of 2 or p of 2.4? P of 2.4, right? So the answer is closer to 2.4. Let's try, let's split the difference. What's p of 2.2? I think it's going to be a negative number. It's negative 7.2, you said? Negative 7.02. So my zeros between 2.2 and 2.4. If they wanted to go 2 decimal places, I'm going to put in, let's be wild and crazy, negative 2.28. And let's see what that gives me. Ooh, negative 1.7. .17. That's going to be the closest I could probably get. Okay? Now, there's a table function in your calculator that you can actually go to and change those intervals. All right? So what time does this bell ring? 57? 47. Okay, we'll show this real quick on here. All right. So this function is x to the 5th gotta go to y equals x to the 5th minus 9x squared minus 15. Okay? So you want to go to your table setup here. See this table setup? Second table setup. We know we were between 2 and 3. So if I just look at my table between 2 and 3, you're going to see the negative 19 and the 147 we started with. Go back to your table setup and say, I want to go to 2 decimal places. We're going to do 0.1 right now. Now you can see we're getting close. It's got to be between 2.2 and 2.3. So we can go back to table setup, start at 2.2, and I want to go by 0.01 because they went to the nearest hundredth. You see here where the sign changes? So it's got to be between these two, somewhere. Which one is it closest to? 2.28, right? So you could say maybe it's 2.22 or 2.21. You can go through there. Okay? So that's a way to estimate it. Okay? We'll talk about it tomorrow. We'll start with the other one.